Hello, my name is Mousam Das. Today I am here to represent our DETC Final Year project, and the name of our project is Real-Time Automatic Plant Watering System based on GSM. The abstract of our project is that basically it is a automatic plant watering system, and since in nuclear families when people don't get time to water the plants, so for that purpose we have designed an automatic plant watering system where we have used a motor which is to be connected with the main supply, and we have to keep the motor always in running condition so that we can easily water the plants. The purpose of our project is, since it is an automatic plant watering system, so the basic criteria is that we have to reduce the manpower. So we don't need any kind of manpower is not needed, since it is an automatic plant watering system. The application of our project is based on agricultural fields. Agricultural fields is a very big application where we can use this kind of plant watering system projects. In hockey fields we can also use it, and for other applications we can use it also. Now for further explanation of our project, we are going to explore the hardware description, software descriptions and other purpose.
Hi, I am Gohana Chakraborty and I am going to discuss the hardware requirements of our project.
My name is Devago Bhattacharya. I will discuss about the software interfacing part. Here we will use the Arduino Uno R3 for Arduino Uno R3 board, and we use the hyper terminal for GSM SIM 900A module.
Hello, I am Santan Nondi. I am going to demonstrate overall project.
Here this is the YL38 moisture sensor, soil moisture sensor. Here VCC pin, a ground pin and AO pin. This is analog pin connected with the Arduino analog pin A0. Here A0. This pin is connected with this A0, and this is one is VCC and one is ground, which is connected to the sensor, a VCC and a ground. And here we take common ground and common VCC from these pins. From this 5-volt pin we take the common VCC, and from the ground pin we take the common ground. Those are connected here. This is the ground line and this is the VCC line. And in GSM, here are 3 pins connected. One ground and another 2 is TXD and RXD pin, which is for transmission and receive. These are connected with Arduino pin number 3 and 2. This TX and RX are connected with Arduino pin number 3 and 2, and ground pin are connected here. This is 16x2 LCD display. Here have 16 pins, and these pins are connected with Arduino pin 13, 12, not 13, 12, 11, 7, 6, 5, 4. And pin number 3 is connected with the port, and the ground or VCC of the port connection are common here. And from pin number 13 we take the output. This is connected with this transistor BC547 through the resistor, and this transistor is connected with the relay, and this relay is connected with the water pump and also 220 volt of the main power supply. And here our power supply for 5 volt, it is given to here. That's all. Here we use Arduino Uno R3 board This is Arduino Uno R3 board, and this is the power supply point of this board. This is the Arduino Uno connector. We connect it from our laptop or computer to here to give 5-volt supply. This is GSM SIM 900A module. We use this module to send alert message to the users. And here we use a 16x2 LCD display. It is 6-volt SPDT relay, and it is the control circuit. Here it is BC547 transistor. It is a diode and a resistor, 1K resistor, and it is 10K resistor connecting with the third pin of LCD display. This is variable resistance, and this is YL38 moisture sensor module. It's the flying fish device of this module. We can vary resistance or vary the range of the sensor from this port. We use 220-volt aquarium pump, water pump, and this is 12-volt power supply for this GSM module. Here is the port. Here is the port to give the power supply. This is 5-volt power supply to give the supply to the relay. These all equipments are required to do the project.
In the software interfacing part, we discuss about the installation requirement, where the SIM900.h header file used for the GSM module and SMS.h header file used for fetch the receive and transmit of the signal from GSM module to mobile, and the moisture level also. Here we used 500. We can change the moisture level, and we used also liquid crystal display. The liquid crystal display pins are used for 12, 11, 7, 6, 5, 4, and the pin number 13 is give us the output of the circuit. And here we also use the print command for the moisture sensor, and we use the 900 and 9600 GSM baud rate, and we also used here the pin number 13 when it is high. If it is high, then it gives us a display water required. If the pin number 13 is low, then it gives us water is not required. It is shown in the display, and after that the message water is pumping from the pump, it is shown in the mobile, in that mobile number. And after that sounds
It is the Arduino Uno R3. It is programmed that if the moisture level is high, the output gets low, and when the moisture level gets low, then output gets high. It is a moisture sensor, and it is sense the moisture of the soil, and it is two probe. When the moisture level is high in the soil, then the two port is shorted. And the output of this soil moisture sensor is given in the Arduino Uno R3. When the moisture is higher in the soil, then when we sorted the sensor, then the output gets low and the motor is off. When the moisture of the soil gets high, the pin is sorted and the transistor is triggered to the relay to turn off the motor. So motor now is turned off. When motor is working, the GSM is send a SMS to the user and it is so that is the overall project.